Okay. In the first example, we need to write this Bayesian estimation example, estimating the bias of a coin. Okay, normally the coin or the chance of the head and tail must be equals to 0.5, but we have a fake coin or the bias of coin. Okay, and so we need to define the number of tosses and observed heads, n equal 10, h equal 7. Okay, and also define the prior distribution. Uniform theta is equals to the line space 0, 1, 1000. Okay, and also prior information must be set with the with the ones, but size of theta. Okay, all the prior information is 1, and then compute the likelihood manually. Okay, normally we have the built-in function in the MATLAB, but we need to write a code manually in here. Likelihood for binomial distribution can be given by p h theta equals to c and h, this is the combinator, theta over h plus times 1 minus theta over n minus h. Okay. This is our formula, and after that we need to compute the binomial coefficients. First of all, c and h binom coef is equals to the factorial n divided by factorial h times factorial n minus h. Okay. After that we need to compute the likelihood for each theta. Likelihood is equals to the binom coef times theta over h dot times 1 minus theta dot over n minus h. Okay. After that we need to compute the unnormalized posterior. For the the unnormalized posterior in here, likelihood dot multiplication prior. Okay. So normalized posterior can be given by with the posterior is equals to the unnormalized posterior divided by traps theta unnormalized posterior. Okay, and so this is a specific function to to calculate the posterior information, which is coming from the our MATLAB notes, or the PowerPoint notes. Okay, after that we need to compute the posterior mean, such as the posterior mean value traps theta dot star posterior. Okay, plot the prior, likelihood and posterior in here. First of all we need to give the figures in here just like this one. Okay. After that subplot 3.11 and the plot theta prior should be given in here with the blue color, okay, and line white is equals to the 2, okay. And so the title prior distribution, but in the uniform, okay. X label theta, Y label probability density, okay. And after that subplot 3 1 2, and the plot, the same condition is given in here. Theta, this is the likelihood, this is green, and this is the likelihood function, this is also theta, and this is the likelihood, okay. Grid 1 must be opened in here, and also we need to copy the last term, theta posterior, this is red one, this is the posterior distribution and this is the probability density, okay. And after all, so we need to print f to what posterior mean estimated bias, which is given by percentage for f new line posterior mean, okay. So if I run this code, and we will have the error at 21 line, just see the 21, oh, I'm sorry, also this one. So if I run this code, just see that this is equals to what, the 0.66, right? And so prior distribution is equals to 1, the likelihood is around to what, the 0.7 at the maximum point, but the probability density function is around to what, 0.666, right? 0.66, okay. This is how we can calculate the estimating the bias probability of a coin for a given observed data, which is given here, okay. And also we can say this is the 100, and then we can calculate this one, just this one, but this is the 73 in here, for example. And so we will have this kind of information, and so the estimated bias 0.72, or if we take the 50 values in here, just like this one, likelihood and the posterior distribution is around what, the 0.5, okay.